Good morning, everyone. I hope everyone's having a fantastic day so far. All right, so I'm going to go ahead and get started. I just wanted to once again thank everyone for coming this morning. Hope everyone's having a great morning so far. So this morning we are hosting this webinar with our great partners over at Bamtech. I have Jared Martin and John Withers with me from over there. We're going to be doing some exciting stuff, taking a look at the VMY systems as well as what we can do with that data in Terrasolid. And Jared's going to show us a bunch of exciting stuff about Bamtech, what they're doing over there, and how Terrasolid's working. So I won't dwell any longer. Jared, are you ready to go ahead and get started with your presentation?
Thank you, Tanner, and thank you everyone for joining us today for utility value extraction with VMY Data and Terrasolid. It is a great pleasure for Bamtech to be able to show a small preview of what is possible in Terrasolid, the industry standard for point cloud intelligence, alongside Riegl, the international leading provider of cutting-edge laser scanning solutions. Quick glimpse at Bamtech. It is a team of subject matter experts with a wide range of practical hands-on experience, from boots-on-the-ground field acquisition to data processing, extraction, and deliverable products. We know the bottlenecks and the pain points because we've done the work. We've been there in the trenches, and we've used solutions we create to improve workflows for our customers around the world from start to finish. Bamtech is also a North American reseller of Terrasolid products and Riegl mobile LiDAR scanners, offering hardware, software, support, and training, all in one company, all to one user. This webinar will be a quick glimpse into updates for using Terrasolid tools to process, edit, and extract features from the Riegl VMY mobile LiDAR data, which was generously provided by Riegl USA. Those who would like a more in-depth experience and to take advantage of hands-on learning opportunity with subject matter experts alongside the Terrasolid team, please consider attending TerraCon 2023 in Kansas City, June 6th through the 8th. For those who are unaware, I'll give you a quick explanation of what Terrasolid is. Whether you are using terrestrial, mobile, unmanned, aerial LiDAR, or a combination of sensor platforms, Terrasolid offers versatile and capable tools to create 3D vector models, feature extractions, orthophotos, terrain representations, and advanced point cloud visualizations, no matter the data source or the sensor. Terrasolid has a long history of elevating data utilization, whether it is for mapping, forestry, water resources, mining, road, rail, or power lines, which we will be focusing on today. A couple of the tools that we'll go over. The first one is TerraScan. It is the main application in Terrasolid software family for managing and processing all types of point clouds. It supports many popular point cloud formats and provides its users the ability to perform automatic routines in batch processes. In conjunction with TerraScan, Terra Modeler provides the ability to create, edit, and utilize those surface models. It provides a wide variety of visualization options and exportable features. Whether or not you're doing bare earth rasters, surface rasters, different visualizations of those rasters, or contours, there's an option in Terrasolid. TerraMatch is a comprehensive tool for improving the accuracy and quality of the raw laser point cloud. It is a robust solution designed for comparing and correcting point cloud misalignments and adjusting to control surveys. It takes what the proprietary manufacturer software has and allows you to combine multiple sensor types or from different vintages, or even taking the data that's already there and just improving it a little bit more for whatever the project requires. The last one I'll mention today is TerraPhoto, which is specifically developed for processing images captured together with laser data. Imagery can be rectified to the co-collected laser data, aiding in positional quality of products generated from either source. It can also be used to fuse the RGB data with the LiDAR point cloud for enhanced visualization, providing incredible detail and ability to use both at the same time. In today's example, we will have a short demonstration of some improvements made by Terrasolid to reduce the effort and complexity of working with power lines. For those of you who have worked with power lines using TerraScan in the past, you'll most likely recognize the familiar process. However, the methods and tools for classifying towers and lines, extraction of the catenary vectors, and analyzing the danger objects or fallen vegetation may look a little different. Terrascan's additional functionality will allow users the ability to perform faster workflows, which will directly affect the overall quantity and quality of the work performed. Starting with exceptional data, like that provided by the Riegl VMY, the extraction process can be as easy as a few clicks. In just a minute, John will show us just how easy the work can be with this impressive toolset from Terrasolid. But first, we'd like to do a quick survey to understand which platform each of you are using to collect your data. I believe we have that survey ready to go.
I just posted it.
Basically, we want to know whether you are using aerial LiDAR from fixed wing or rotary, mobile, unmanned, or even if you do not collect LiDAR at this time. Each way has its pros and cons, but in all cases, a singular method for acquisition may not be the only option. What we have right here with the VMY, it can be used completely solely or in conjunction with another sensor platform to generate incredibly detailed data sets. Polls coming in, and it looks like most of you are going for the mobile option. That is encouraging.
All right, I'm going to go ahead and close the poll since it looks like a majority of people have voted who is here. But yeah, Jared was correct. It was 64% voted mobile LiDAR.
So this webinar is for all of you, or at least the majority. I think that was the only poll we were actually going to do. Or did we have another?
That was the only one.
Okay. Well, in that case, I will pass it over to Tanner to go over the Riegl VMY range.
Let's see. I believe everyone can see my screen now. All right. Well, thanks, Jared, for that great overview of the work that Bamtech is doing, as well as a great overview of all the tools and other applications that people are using in Terrasolid. So today, I will be just doing a quick little overview of the VMY mobile LiDAR systems, really digging into their configurations, the main differences between the VMY-1 and 2, and just showing the solution overall. So looking at the VMY, a good highlight of the systems is they are more small, compact, fully integrated mobile systems. Due to their size and price, they really do make a great entry point into the mobile LiDAR space. They're small, they're compact. The prices, at least comparatively across, are lower compared to the larger systems like the VMX or the VMQ. With that in mind, they also make great secondary systems. I'm sure it looks like a lot of you are using mobile LiDAR. A lot of the mobile LiDAR systems do not stay still. They're constantly collecting. So from a company perspective, if you're ever running into a situation where you're overbooked your LiDAR system, having a smaller, compact LiDAR system as a secondary system for those smaller jobs, especially to ship around for rental car installation and things of that matter, is a great application for these systems. Another great thing about the VMY systems is we can integrate multiple sensors, IMUs, and camera configurations. So really no matter your project size or your budgets, we have a solution there that we could see if we could work with. So digging into the first sensor in the line, which is the VMY-1. So the VMY-1 uses a single minivux scanner. So the same sensor types you see on a lot of our drone platforms, it's the same, it's the minivux scanners. They have multiple scan angles. So the VMY-1 platform itself sits on a swivel plate, very similar to the VMQ, if anyone's familiar with that system. And it can scan at that +15, 0, -15 angle. What that allows you to do is be able to basically produce the same data that you're getting from a dual head scanner with multi-passes. So you could scan at -15, you could scan at +15 and produce the same data that you would see with a dual head sensor. The setup is very low key. The footprint's very small. It's just a simple power supply box that sits in the vehicle and a laptop to run the sensor. The big selling point and a great use case for the VMY-1 is that it is a dual use system. So our new integrations, the IMUs, are actually directly mounted to the scanner in the system. So you can actually be taken out of the case and placed on a ULS platform. So this is just a quick look at the actual carry case and shipping container for the VMY-1. As you can see from a footprint perspective, it's very small. It's a very small Pelican case where you can fit the sensor, the antenna, and all your cables. So you could theoretically have this in another accessory box and be able to move the system around very, very easily. Looking at some of the configuration options, starting on the IMU side, we can integrate both an APX15 and an APX20 into the VMY-1. Both are great IMU types, depending on the price you're trying to go for. The APX15 allows for 2 camera options integrated, and the APX20 allows for up to 4, which is great. And our multiple sensor options is the MiniVux-1 UAV, the MiniVux-3 UAV, and the new MiniVux HA sensor. So as you can see over here, we have just a small view of their actual density you'd be looking at. So it basically starts at 100,000 points per second with the Mini-1 and works its way up to 300,000 points per second with that Mini HA. The MiniVux-3 can do 300,000 points a second, just only in the 180-degree field. So that'd be if you're placing on a drone platform, you can get the 300,000 points a second. But if you're wanting the 360 degrees from the mobile sensor, which you would, it can only scan at 200,000 points per second. So there is a very big benefit to owning a dual use system. So as a lot of you know, mobile systems can access certain areas better than ULS systems, and the same way around. There's places you can fly that you cannot drive. So when you combine data sets from those 2 applications, it really helps paint a whole picture of the landscape. Your mobile system can drive roads much faster, and it's a lot denser since the targets are closer than a UAV platform. But there's areas where you're not going to be able to reach with your vehicle, and sometimes it would be easier just to throw it in the air on a drone. So just kind of showing that basically the size of the system to that integration kit. Right now, I could probably do it faster than 30 minutes, but I think 30 minutes is about the change time to get the sensor and IMU out of the VMY-1 and onto a mobile platform. So you could basically do 2 different collects in a single day. It's a pretty easy system. Digging in more into the VMY-2 or the dual head option. So just like the VMY-1, we're using the MiniVux scanners, except that there's 2 this time. It has the same form factor in that the basic configuration is ran with a simple laptop and power supply box. But we do offer integration with an IAU unit that expands the camera configurations, which we'll get into that in a little bit. And we offer different configurations with higher end IMUs, which we do not with the VMY-1. So getting into those configurations, as you can see, the laser sensor options are the exact same. We can integrate from the Mini-1 all the way up to the Mini HA. But you'll see that the IMU options have changed. So we can integrate either the AP20 IMU, or the big note here is we can integrate the AP60 IMU as well, which is the same IMU that the VMX is using. So it's a high grade survey IMU that allows the if you were to do configuration, for example, with the VMY-2 with the Mini HAs and the AP60, you're getting 600,000 points a second due to the dual head system. With a high grade IMU like that, can really help do survey work at a very, very good fast pace for a very small system. Just wanted to show off the different camera packages and what that actual interface unit I mentioned earlier. So instead of having a laptop in the vehicle, you would have one of these interface units in the vehicle, and it's a dedicated computer to actually run the system. The big selling point behind this and why it's great is the IU allows for integrations of Riegl's asset cameras. If you're familiar with the VMX or the VMX-2HA, you notice that we have those asset cameras where you can see the multiple different angles. Those same cameras can be integrated into the VMY-2 using this interface box. So you could use the cameras swappable, interchanged, or just order separate cameras dedicated for your VMY-2. The other selling point is it has the dedicated hard drive base, just like you would see on a VMX CU box. So as you see on the right-hand side of the box there, we have two hard drives bays in there for you to integrate those in. So just kind of showing what this camera package looks like, or at least what the basic configuration looks like. First, as you can see, it's a simple mechanism of using our VM power supply box linked up with a laptop to run the system, and either the Nikon D50 cameras or the FLIR Ladybug, or really any 360 cameras that Riegl integrates. Looking at that setup with the IU box looks a little different. So you'll see that the IU box is basically taking place of the laptop in that entire equation, and it's actually hooked up to the power supply box directly. And now we can, with that integration, we can now operate those Riegl cameras. So for you, this is kind of a good screenshot for you guys familiar with VMX data. Of course, you know, the VMY with the Minivux scanners cannot produce the same kind of data, but it's pretty replicable but between the two, especially if you're looking for the smaller jobs. So this is just two examples of the exact same turn arrow, the exact same lane driven. Both of these were single pass. Both were driven about 45 miles an hour, and this arrow was about 15 feet from the sensor. So you can see there with the VMX data, of course, looks denser, but we're not really losing that much edge detection on this turn arrow comparatively to the VMX. It's still comparable data that can be used for a lot of great applications. So just because we're using Minivux scanners doesn't mean the data is awful. It's actually really great for the size and the price that we're selling it at. That is all I had today on the VMY-2 and VMY-1 configurations. I'm now going to turn it over to John with Bamtech, so he can actually show us what we're doing with this data collected from the VMY-2.
And what I've got is just a little video that I recorded showing the general workflow for extracting power lines from mobile data in Terrascan. So basically what I've got are some lines, 2D lines, that I'm going to use as alignments for my power lines. And I've got a point cloud that has been classified with a ground class and low veg, medium veg, and high vegetation. So that's my starting point. So first thing I'm going to do is drape these 2D alignment lines to my ground class. And that'll help when I need to specify an elevation when classifying power poles. You could leave them at 2D. You don't have to drape them, but I prefer to have them at the ground level. Next thing I'm going to do is classify by center line around all these alignments, and I'm just going to create a buffer in a temp class from my high vegetation. So that will include my power poles, my lines, any vegetation within a 5-meter corridor of my alignments. So you could see now the blue points are a temp class. And I'll use my main alignments to classify the poles around the vertices. When I drew these 2D lines before they were 3D, I put a vertex at every power pole. So now this routine will basically just classify an area around each vertex to represent our power poles. So now at this point, I'll select one alignment and I'll run the Terrascan tool, find power line wires. and it will classify my point cloud and vectorize these wires on the overhead line level. And these numbers, depending on your data set, you might end up playing around with them a little bit just to fine tune it, find that sweet spot that the routine likes. But once you find those numbers that work for your data set, this routine works amazingly well. So I've just got one alignment selected, and it's just going to look for lines parallel to that alignment. But you can see all the yellow in my view too. Those are all vectorized lines that it picked up from the point cloud. And there's probably some cleanup to do around anywhere where vegetation might obscure the endpoints. This routine works best with one alignment at a time. So for any offshoots or secondary, you just select another alignment like I have here, rerun the process, and it'll classify and vectorize any wires that it sees. In this case, you can see that it got confused with some of the lower wires. But Terrascan has an option where you can manually place a wire string, and it's really simple to go in and add in any lines that it may have missed. On this one, this data set, it did a great job finding the main lines. But as you can see, some of these side ones where the data might not have been as dense or the lines are very close together, it missed a couple. But with just a few clicks, you can go in and specify the line location, and it will classify the points and create a vector. Once you've got these vectors, you can then start searching for any vegetation that might be encroaching on your alignment, or search for any trees that might hit these power lines if they were to fall. So I created a macro where I'm going to classify from my high vegetation class to 3 different grow-in classes. Basically, I'm going to classify any vegetation within 5 meters of my wires, another class with any vegetation within 3 meters of my wires, and a final vegetation class with any points within 1 meter of my wires. Those will be my grow-in classes. And then the last step, I will also look for trees that are a falling hazard. So here what I'm going to look for are any trees with a max height of 30 meters that are at risk of hitting these lines if they were to fall. I'll run that. And you can see it returned quite a few points from each step in that macro and colorize them accordingly. So these are all the trees that are at risk of hitting these power lines if they were to fall, or any lower vegetation, I guess higher vegetation as well, but any other vegetation that's within 5 meters of our lines. And you can see here the different rings, the red, orange, yellow, and then the red that slopes up would be our falling danger classes. And that's about it for this workflow. As you can see, it was very quick, fairly easy to complete. And pretty straightforward once you understand the workflow and what the software is doing. It's a very fast workflow.
Yeah, and one of my favorite parts about that and that data set is it really shows off the importance of having sensors with capabilities of multi-returns, right? We get much more out of our data working through road sets that way. When you have multi-returns and you're really getting great vegetation returns well into the forest, you can do a lot deeper analysis with that.
Yeah, definitely. And again, I was very impressed with how well the routine still could find the lines even when they were pretty covered with vegetation in some areas, some of those lower lines. So it was a great data set. Thank you, Tanner, for sharing that. And it's an awesome workflow.
All right, well, thank you, John, for taking us through the highlights of this updated Terrasolid tool set. And obviously, thank you, Tanner, as well as Riegl USA for providing the stellar data from the VMY to perform this work on.
Of course, no problem.
Great. At this time, I think we have a little bit of time to take some questions, if there are any. I'll go ahead and take the screen back.
I have one from one question here. That's what was the distance on the LiDAR data set? So total, that drive was about 2 miles of scanning. And just to kind of give you guys more of a background on that data set in particular, it was about 2 miles of road up in Oregon that we scanned using the Minivux 3 UAV integrated into a VMY-2. So that wasn't even, that data you saw there, it wasn't even from our highest power sensor. It was actually from the Minivux 3. So it's shooting about 200,000 points a second. So on a multi-pass road. So of course, if anyone wants the data set, I would be more than glad to hand it out. If you just email me or request it here, I would be more than glad to hand it out. Any other questions?
Well, if there are any more questions rolling in, if you guys do have some time, or you are interested in some more hands-on training and support, please consider registering for the TerraCon event in Kansas City, June 6th to the 8th. We'll be there with the Terrasolid developers. Riegl USA will also be in attendance, providing an up-close look at some of the most recent LiDAR scanners available now. You can always visit the Bamtech website for more information or reach out to me directly. It looks like we might have had another question.
To answer one of them real quick, this will be available later. There'll be links sent out to the download, as well as on our YouTube channel, Riegl Video Labs. So the other one's about Terrasolid. I'll let you have that one, Jared.
Okay. At this time, Terrasolid is not available in AutoCAD. That's not saying that it won't be in the future, just at this current moment, it is not available.
It is available with a program called Spatix, which is a free download if you own a Terrasolid license. So it is not necessary to work in Bentley or own Bentley licenses in order to use Terrascan and Terrasolid products.
Are there any integration for Terrasolid with ArcGIS Pro? Do you guys, Jared, do you have anything to speak on with that?
Again, similar to AutoCAD, at this time, no, there is no integration with ArcGIS Pro, but that's not to say that it won't happen in the future. There are some tools in ArcGIS Pro that can give you some similar functionality. However, in our experience, the Terrasolid tools are superior in Bentley or Spatix.
All right, any other questions? I don't see any more. Well, I just want to thank everyone for coming to today's webinar. And of course, thanks to Jared and John for joining us and helping us present. I hope everyone has a great rest of their day. And like I said, this will be posted later. So hope everyone has a great day, and I'll always feel free to reach out if you have questions.